Hello and welcome to GER Hub Mathematics and Statistics lessons. In today's video, we shall be looking at a set of problems in our solver series on indices part 1. Thank you very much for your subscription so far. Please subscribe to our channel for videos on mathematics, statistics, and even research. Okay, research project writing. Thank you for your subscription so far. Please like our video, watch our video, share our video, and most importantly, we keep emphasizing, please subscribe to the channel. That being said, let us begin. In today's video, we shall start with problem 1, where we shall consider A, B, and C, the problems in A, B, and C. So let us start. Now, I'm going to start with problem A, where we are given a problem 2 raised to power x equals 0.125. So how do we go about solving this problem? We shall start in this manner. Now, the first thing you do in solving a problem like this on indices, usually called an exponential equation, is to reduce both sides to the same base. Now, take note, on this side of the equation, we have 2 raised to power x. On this side, we have 0.125. Okay, so the strategy for solving exponential equations in this manner is to reduce both sides of the equation to the same base. So I'm going to start with a first step, maintaining 2 raised to power x on the left hand side, but on the right hand side I'm going to write this as 125 all over 1000. Now, how did I get that? Converting this decimal to fraction requires that I move the decimal point 1, 2, 3 times. Okay, so for every time the decimal point moves, it is presumed that you are dividing by 10. So by the time you get to this point where it becomes a whole number, it means you must have divided by 10 times 10 times 10, and that gives 1000. Now that brings us to 125 all over 1000. What have I done there? I have just converted the right hand side to a fraction. Now remember, the focus remains converting both sides to be in the same base. So this gives us 2 raised to power x equals a simplification of 125 all over 1000. And so what do we do there? We shall divide 125 and 1000 by what is common to them both, okay, and then reduce them to something reasonable. Okay, so in this case, I'm going to start with dividing 125 by 25, and that will give me 5. Okay, and when I do the same thing for 1000, it will give me 40. So if I keep dividing, 5 will divide 5, and 5 will divide 40 to give 8. So what I have here is 1 over 8. Okay, now the next thing I will do, still on the interest of reducing both sides to the same base, is to write 1 over 8 as 1 over 2 raised to power 3. Of course, this is not wrong because 8 is the same as 2 raised to power 3. Now, by this law of indices that says a raised to power minus n equals 1 over a raised to power n, by this law of indices, I'm going to convert this right hand side to 2 raised to power minus 3. So it becomes 2 raised to power minus 3 because of this law. Okay, now what have we done so far? We have been able to reduce both sides to the same base. Remember, solving an exponential equation in this manner requires reducing both sides of the equation to the same base, and by implication, if both sides can be reduced to the same base, automatically the powers are equal. So provided this is 2 raised to power x and this is 2 raised to power minus 3, the bases are the same, 2 and 2, it implies that x is equal to minus 3. Okay, and that solves that problem. Now, if you move to the second problem, we are asked in the second problem to obtain the value of y. Okay, we are asked to obtain the value of y. So we are given 3 raised to power minus y equals 2 raised to power 43. Again, the task remains to reduce both sides to the same base. So I'm going to write this as 3 raised to power minus y on this side, and I'm going to think about it. How many times will I multiply 3 to give us 243? So 3 times 3 is 9, times 3 gives 27, times 3 gives 81, times 3 gives 243. So it means it will take 3 raised to power 5, that is 3 multiplying itself 5 times to give 243. Now once you can do that, automatically the powers become equal, meaning that minus 5 is equal to minus y is equal to 5. Okay, now but remember, the problem is not to find minus y. The problem is to obtain y. So what we end up doing is to divide both sides by minus y. Now if I divide both sides by minus 1, rather, I'll end up having 5 divided by minus 1. Now why am I dividing by minus 1? It is to ensure that the result gives y, meaning that we want y, not minus y. So dividing both sides by what stands beside y, that is the coefficient of y, which is minus 1, gives us y on the left hand side equals minus 5. And that solves the problem. Now to ensure that the problem you are solving is actually correct, all you have to do is to test your solutions. Okay, test your solutions by putting the value of y back into the problem, and it will end up giving you 3 raised to the power minus times minus 5 is 243, and that shows you that the problem is correctly solved. Now let us go to C. In C, this is for B. In C, 1C, we are asked to obtain z, meaning we are asked to solve this exponential equation. 25 raised to the power 5z equals 625. So what I'm going to do here is to reduce both sides again to the same base. Now how do I reduce both of them to the same base? Looking at 625, take note, 625 can be reduced to 25 raised to the power 2, because 25 raised to the power 2 gives 625. So 25 times 25 will give you 625. And on this other part, we maintain 25 raised to the power 5z. Okay? Now, because both of them have this are in the same base, it means that automatically their powers are equal, and this is 5z equals 2. But we don't want 5z. The solution to this problem is the value of z, not 5z. So we are going to divide both sides by what stands beside z, and that is 5. So dividing both sides by 5 gives 2 over 5 on the right hand side and 5z over 5 on the left hand side. Now once 5 cancels 5 on the left hand side, you end up having z equals 2 over 5. And that solves the problem 1. Okay? Now you go over it again and see what we've done. Let's go to problem number 2. Now in problem number 2, our objective is to solve this. Okay? So we want to solve this in problem number 2. Problem number 2 gives us, to start with, it gives us 4 over 2 raised to the power x. So I'm going to bring that problem here. 4 over 2 raised to the power x equals 64 raised to the power x. Okay? Now, 4 over 2 raised to the power x equals 64x means 64 can be written as 2 raised to the power 6. Because 2 times 2, which is 4 times 2, which is 8 times 2, which is 16 times 2 gives 32. That's 2 raised to the power 5. Then 2 raised to the power 6 will give you 64. So I can write this as this. Okay? And on the right hand side, or on the left hand side rather, I can write 4 as 2 raised to the power 2. And this becomes 2 raised to the power 2 all over 2 raised to the power x equals 2 raised to the power 6x. Now, how did I get 2 raised to the power 6x? Take note, there was a law in indices. A raised to the power mn is equal to a raised to the power m times n. So whenever you have a number in exponential form or index form raised to another power, the result is that number raised to the product of the powers. Okay? And that was how I got 2 raised to the power 6x, because 6 multiplies x to give you 6x. Okay? Now, on the other side, I'm going to do this. I'm going to write 2 raised to the power 2 minus x. And this is coming from what law of indices? A raised to the power m minus n is equal to a raised to the power m divided by a raised to the power n. So look at it. You have 2, 2, a. M is 2. In this case, n is x. Okay? So that will give you that result. And that means we now have this. Okay? So 2 raised to the power 2 minus x is equal to 2 raised to the power 6x. And automatically the basis, because they are equal, implies that the powers are equal. So this will be 2 minus x equals 6x. Now, what do we do next? We are going to solve for x. So I'm going to bring this to this side and it becomes positive. So this becomes 2 equals 6x minus, 6x plus x. And that gives me 7x equals 2. So you can actually write that as 7x equals 2. And x, when you divide both sides by 7, when you divide both sides by 7, x becomes equal to 2 over 7. Okay, so the solution to that problem becomes 2 over 7. Now let's go to problem B of number 2. In problem B of number 2, we are given 10 raised to the power x equals 1 over 10,000. Okay, now 1 over 10,000 can be written as 1 over 10 raised to the power 4, because 10 raised to the power 4 will give you 10,000. Now, by this law again on indices, a raised to the power minus m equals 1 over a raised to the power n. By that law of indices, we can actually express our right hand side 1 over 10 raised to the power 4 as 10 raised to the power minus 4, and this is 10 raised to the power x on the left hand side. Okay, now because both bases are the same, automatically the powers are the same, and that gives us x equals minus 4. Now that solves problem B of number 2. Going to problem C of number 2, what are we asked to obtain? We are given 10 raised to the power y equals 1 over 0.001. So 10 raised to the power y equals 1 over 0.001. Okay, now what are we to do? Again, our interest will be to reduce both sides to the same base. So to do that, we would have to start with converting this fraction over here to something easier. Okay, so I'm going to write this as 1 over 10 raised to the power minus 10 raised to the power minus 3. But before I do that, let me show you that this is the same. 0.001 is the same as writing 1 over 1000. Okay, again, how many times will the point move to get 1 as a whole number? It will move 1, 2, and then 3. So by the time the point moves 3 times, it makes 1 a whole number. And take note, every time the point moves, it divides 1 by 10. Okay, so by the time it gets to this point, it must have divided 1 by 10 times 10 times 10, which is 1000. So that gives us 10 raised to the power y equals 1 over 10 over 1000 rather. Now take note again, because there is a rule of reciprocals that 1 over a over b is the same as b over a. We shall apply that rule in this case. Now what we have, I'm bringing it over here, 10 raised to the power y equals 1 over 1 over 1000. And this is similar to this rule. By that, we end up having 1 over 1 over 1000 is the same as 1000, because you are taking the reciprocal of a fraction, a over b, in this case 1 over 1000. So the numerator becomes the denominator, and the denominator becomes the numerator, and that gives you 10 raised to the power y equals 1000. Now 10 raised to the power y is equal to writing 1000 as in, or writing 1000 in exponential form, and that will give you 10 raised to the power 3. Now because we have reduced both sides to the same base, automatically the powers become equal, and y is equal to 3, and that solves the problem. Again, you can verify your solutions by putting the values of y back into the problem to see if it reduces to the result we have on the right hand side. Okay, now that being said, let us go to problem number 3. In problem number 3, what we want is to solve the following problems. 32 raised to the power 3 over 5. Let's start with this. A. It says evaluate the following. 32 raised to the power 3 over 5. So we shall be applying the laws of indices here. So this is 32 raised to the power 3 over 5. What is it equal to? Now remember, I can write this as the fifth root of 32 all raised to the power 3. Take note, what law are we applying here? Remember, there was a law of fractional index. The law of fractional index. So that will be m over a raised to the power 1 m over n is equal to the nth root of a all raised to the power m. This is the law that makes the right hand side here become this, the left hand side become the right hand side. It is by this law of indices that this left hand side becomes the right hand side. Okay, so in this case your n is 5, your m is 3, so that gives you the nth root of a all raised to the power m, which in this case will be the fifth root of 32 all raised to the power 3. Now that being said, what is the fifth root of 32? The fifth root of 32 is that one number that will multiply itself 5 times to give 32. So what one number is that? The number that will multiply itself 5 times to give 32 is 2. So it means that the fifth root of 32 is 2, and that gives us 2. So what is inside the bracket is 2. What remains outside the bracket is 3. So 2 raised to power 3 is 8, and our result is 8. So when you evaluate 32 raised to power 3 over 5, the result gives you 8. Now, let's go over to B. Problem number B. Problem number B requires that we obtain 25 raised to power 1.5. So this is what we are asked to do. So let's evaluate this. I would start by writing 25 raised to power 1.5 as 25 raised to power 15 all over 10, when 1.5 is converted to a decimal, a fraction rather. Now take note again, the point moves just once, meaning it divides 15 by 10 to give 1.5. So if you reverse it from being a decimal to a fraction, it becomes 15 over 10. So 25 raised to power 15 over 10 is what we have over here. Now what do we do? The next thing is to simplify. So I'm going to write 25. 5 can divide 5 to give 15 to give you 3. 5 can divide 10 to give you 2. Now again, it brings us back to what we had done earlier. This law, a raised to power m over n is equal to the nth root of a all raised to power m. So I'm going to apply that law again. And what would it mean? It will mean taking the square root of 25. Take note, when referring to the square root, you don't put 2 in here, okay? It will be wrong of you to put 2 in here by notation. You just put the root of 25. So the root of 25 is the same as the square root of 25. So the law still applies, and this is raised to the power 3. Now the question is, what is the square root of 25? The square root of 25 is that one number that will multiply itself twice to give 25, and that number is 5. The only number that can multiply itself twice to give 25 is 5, and that makes 5 the square root of 25. So that will become 5 raised to power 3, and 5 raised to power 3 is 5 times 5 times 5. In this case, 25 times 5, which is 125. Okay? So the result we have for evaluating this is 125. And that brings me to problem number C. Now for problem number C, we have 343 raised to power 2 over 3. We are asked to evaluate this. So we are going to write this based on this law again as the cube root of 343 all raised to power 2. Now, what is the cube root of 343? It is that one number that will multiply itself 3 times to give 343. So this cube root of 343 is that one number that will multiply itself 3 times to give 343. So what one number is that? The only number that will multiply itself 3 times to give 343 is the number 7. So 7 becomes the cube root of 343, because 7 times 7 is 49. 49 times 7 will give you 343. So all in bracket squared. So what is inside the bracket when simplified gives 7. So we bring the square over here. Now what is the square of 7? It is 49. What that means is that evaluating this problem, 343 all raised to power 2 over 3 gives you 49. Okay? And that brings me to problem number 4. Now for problem number 4, we have the following. So I'm going to start with problem A. Problem A requires that we simplify or we evaluate this. So I'm going to write 0.0000 0.00001 all squared. And that problem is solved by first of all tackling what is inside or within the bracket. What is inside the bracket? You think about it. How many times will the point move to make 1 a whole number? It will move 1, 2, 3, 4, 5. So this becomes 1 over 10 times itself 5 times. That is 10, 10, 10, 10, 10. Okay? 100,000. So all squared. So that will reduce to 1 over 10 all raised to power 5. So I can write it in this manner, all squared. Now that is because 0.00001 is the same as 1 over 10, 100,000, okay? And that will give us 1 over 10 raised to power 5. Now, if you do that, it will end up giving you 10 raised to power minus 5 by the law of indices. And by the law of indices, you now have 10 raised to power 5 times 2. So this should be 2, okay? Now, that gives us 10 raised to power minus 10 as our result, okay? So how did we get that done? All we had to do was, at this point, apply the law, a raised to the power minus n, a raised to the power minus n is equal to 1 over a raised to the power n. Okay, so that law was used here, and it reduced it to 10 raised to the power minus 5 with all squared coming outside the bracket. Now, by this law again, a raised to the power m raised to the power n is the same as a raised to the power m times n. We got 10 raised to the power minus 5 multiplying 2. Minus 5 times 2 gave us minus 10, okay? Now, that solves that problem. And we now come over to B. For problem B, we are asked to find or simplify or evaluate 216, that is 216 all raised to the power 4 over 3. Now, when you solve this problem, you are going to end up having the cube root of 216 all raised to the power 4. Now, the question is, what is the cube root of 216? The cube root of 216 is 6, because 6 is the only number that will multiply itself 3 times to give 216. 6 times 6 is 36. 36 times 6 will give you 216. So the problem reduces to 6 in that bracket all raised to the power 4. Now 6 in that bracket all raised to the power 4 is 6 times 6, that is 36 times 6, 216 times 6. So 216 times 6 is what the problem reduces to. Let's see what that gives. So 6 times 216 is 36. 6 times 6 is 36. If you take 3 above, 6 times 1 is 6 plus 3, that gives you 9. 6 times 2 is 12. So the problem reduces to 1296, 1296, and that solves problem B. Okay, so what did we do again? 2 raised to the power 216 all raised to the power 4 over 3 is the cube root of 216 by this law of indices again. This law we had used severally in this video. That is, the nth root of a all raised to the power m is a raised to the power m over n. That is the law we have used, and that brings us to this. But the cube root of 216 is that one number that will multiply itself 3 times to give 6 and to give 216, and that result is 6. So 6 raised to the power 4 is what the problem reduces to, and 6 raised to the power 4 is 1296. Now let's go to the last problem here. What is problem C saying? 19 raised to the power 0. This is a simple problem because anything raised to the power 0 is 1. 1 million raised to the power 0 by indices is 1. Anything at all raised to the power 0 would give you 1. And that brings me to the end of this problem solving series on indices. Do like our video, share our video, watch our video, and most importantly, subscribe to our YouTube channel to grow our channel for us, to support us, and to make sure you get notified on any new video we upload. Thank you very much, and thank you very much.